Continuing with rational expressions, seen here we're being asked to add or subtract as indicated. The main difference between the previous problem when we were multiplying and dividing is that the denominators really did not matter in the sense that they could have been different, but since we're adding and subtracting rational expressions in this case, this is a big part here, we need to have denominators that are the same. And that's crucial because if they aren't, then we cannot really add across like we might think that we can. So in this case, our main subtle goal is to get common denominators. This is our goal at first, and then we'll focus on adding and subtracting the like terms. But this is our main goal, because if the denominators are not the same, we can't do much. If you're not convinced, if you were going to try and add a half and a quarter, this wouldn't just be 2 over 6, meaning 1/3, because you have a half and a quarter. 75 cents is not the same as a third of a dollar. So please consider trying to rewrite common denominators like you would with cross multiplying. With this, we have a little bit of factoring to do with our denominator. We'll start with that. So we could rewrite this. We have a product of 40. We have a sum of -3. Thinking of 8 and 5, yeah. X minus 8, x plus 5. For our numerator, this has a little bit more going on with it. The first term needs to multiply and get 5x squared. 5 is a prime number, so we can just have 5x and x. We need a product at the end that gets us 4, and the only options there are 1 and 4, 2 and 2. This is a negative product, so we want to have one of these be negative and one be positive, but we also want to be strategic about it. I think the best way to approach this is to just think out some of these numbers. So we know that we need to have this go a little bit further. We know that we need this product of 4. This is sometimes where you can modify diamond method and take this a little bit further. So we know that our first term is 5, the last term is -4, which should give us -20. This is -25. We might not be able to do too much as far as simplifying this. So we'll actually jump back to this in a second. So we might just leave this as is. This might not be factorable. With that being said, if we take this along to the right-hand side, we're adding on 2, and then x minus 8, deducting 3x over x plus 5. So looking at this more closely, I'm going to go ahead and say that this isn't factorable, because if it was, we would be able to end up with factors of -20 that, when added together, get us -25, and I really can't think of any. So let's assume that this is going to stay as is. So if I start this fresh, keeping our numerator as 5x squared minus 25 minus 4, because this is not factorable. And then x squared, we then wrote to x minus 8, and then x plus 5, adding on 2, and then x plus minus 8, minus 3x over x plus 5. Again, so we're trying to get common denominators. We already have x minus 8 and x plus 5 in this one fraction. We're nice enough, or the creators of this problem were nice enough to use those denominators again here and here. So to get the common denominator of x minus 8, x plus 5, what would we have to multiply this by? Or what would have to be thrown into the mix for this fraction to have the same denominator as this fraction? hopefully you're saying that this needs to be multiplied with x plus 5. So if we multiply this, the top and the bottom, with x plus 5, we'll evaluate that in a second. This would need x minus 8 because this only has x plus 5 currently. So if we multiply this with x minus 8, top and the bottom. From here, we will then eventually have the same common denominator of x plus 5, x minus 8. So for now, I'm just going to focus on the top because I can do this. Our denominators are the same. X minus 8 is here, here, and here. X plus 5 is here, here, and here. So if I rewrite just the numerators, we have 5x squared minus 25x minus 4, distributing 2 to x plus 5 would add on 2x plus 10. We're then deducting 3x squared, and we're also going to be adding on, careful here because we're subtracting 3x, but 3x is multiplying with this. So negative 3x times negative 8 gets us positive 24x. When we take this further, combining like terms, x squared terms can go to 2x squared. Negative 25x plus 2x plus 24x. That gets us just 1x. Negative 4 plus 10 adds on 6. And our denominator comes back into play here. So this was just the numerator we were working with, but when we go for the final answer, we want to include that x minus 8, x plus 5. So this would be our final answer. So notice that first polynomial or trinomial, 5x squared minus 25x minus 4, was not factorable. We then aborted that. We did not touch it anymore. We just kept it as is, but we could factor the denominator. Again, our goal was to get common denominators. We then cross-multiplied to make sure that the other fractions share that same denominator of x minus 8, x plus 5, because this had the most amount of terms in it. We then combined like terms for the numerator and simplified to here.